Hello and good afternoon, CTS 110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Net Plus, the CompTIA Net Plus course, and this afternoon's video tutorial is going to be a deep dive into the Unit 3 worksheet, which is actually due this evening by midnight, and this is our binary to hex to decimal conversion worksheet, where we're continuing to get in some additional work in making sure that we understand how to properly convert from one form to another. All right, so if we were to start over here, you can see that a nibble, remember that a nibble is 4 bits or half of a byte, and that the nibble decimal values, because we're talking about the low order, so we'll say the low order 4 bits are going to be bit position values of 8, 4, 2, and 1. Now remember, we're talking about binary, so the value is either on, which means it's a 1, or it's off, which means the value is a 0. So when we come up here, we've got our values logged in for us here, so 1, 2, 4, and 8, and depending on which position is on, dictates what that decimal value would be, and then from the decimal value, we can easily ascertain the hexadecimal value. Remember, hexadecimal is 0 through 9, and then A through F. And so then we have a byte. Remember that a byte is 8 bits, so it's 2 nibbles that are together. And as they continue to add on the second nibble, or the high order, right, and think of it high as the fact that higher numbers, 16, 32, 64, and 128, that as we add these high order values in, the numbers increase. And so in those 8-bit positions, when they're all on, the maximum value is 255. So in binary, if the 8 position and the 2 position are on, that gives us a decimal of 10, right? Because we add 8 to 2. We get 10. And in hex, we know that 10, because again, remember, we stop at 9, 10 would be A. And you can see that right here. There's 10, and 10 is A. So it would be 0A. And then the hex notation is 0x. And this is something that you'll see sometimes in computer programming. You'll see that 0x followed by the actual hexadecimal value, because the 0x indicates that what follows the x is the actual hexadecimal value. So 27, right, in binary would be 000111011. That's 27 in decimal. In hexadecimal, it would be 1b, because remember, for the hex, we split it down the middle into 2 nibbles, and this has a value of 1, and this has a value of 8, 10, 11. And remember that 11 in decimal is B in hexadecimal, so you would write that 0x1b. All right, now let's move on to the worksheet over here. So we've got the values across the top, right? They're broken down into the 2 nibbles. So decimal 4 in binary would be 0, 0, 0, 0, and then 0, 1, 0, 0. So that would be decimal 4. In hex, it would be, we draw the line down the middle, we end up with 0 for the first hex character, and then 4 for the second hex character. So it would be written 0x04. All right, so now let's continue on through the exercise here. So 14 is going to be 0, 0, 0, 0, and then we'll put our little break in there. Then the 8-bit value would be on. The 4 would be on to make it 12. The 2 would be on to make it 14. And then our final value would be 0. So what would 14 in decimal be in hex? Well, again, we just break it into the 2 nibbles. So the first one we see is 0, and the second one has a value of what? 8, 12, 13, 14. So do I write 14 here? No, remember, all we have to do is reference our chart here, and we can see that 14 in decimal is equivalent to the letter E. So it would be 0E. Now, written as hex notation, it would be 0x, 0E. I'll put the strikes through. All right, so now we've got 39. So let's work that out. So 128 is off, 64 is off, 32 is going to be on. So as soon as I do the 32, 39 minus 32 is 7. So I know I need to make 7. And remember, the last 3 bits are 4, 2, and 1. So I would put the 0 there, draw my little line in there. The 8 is going to be off, and then 4, 2, 1. So what would this be? Or I should say that is 001, 00111 is 39 in decimal. In hexadecimal, it's 2, and then 4, 2, 1 is 7. So we're going to have 2 and then 7. So 39 in decimal is 27 in hexadecimal. So then written in hex notation, we would have 0x. And in fact, you could quickly, because you know that each one of these, because we're doing hex notation, we'll start with 0x. So let's get these all filled in right now. There we go. All right, so 95. Well, 128 is larger than 95, but 64 is not. Now, 64 plus 32 would be 96, so we can't do that. But 64 plus 16 is going to give us 80. So now we only need 15. And there's that number 15 again. So remember, and I'll put that little squiggly down the middle. Remember, 15 is when all 4 low order bits are on. So 0101, 1111 is 95 in decimal. Again, we've got 64 plus 16 is 80, plus 8 is 88, plus 4 is 92, plus 2 is 94, plus 1 is 95. But what does that work out to in hex? Well, we've got the 4 position on and the 1 position on, so 5, and then all of these are on, which means 15, or in other words, F. So 0x5F. Now we've got 101, so 128 is still too large, but 64 is not. 32 makes it 96. So now, at 96, I only need 5 more. So I know that that would be the 4 and the 1. So everybody else is going to be zeros. And then there's my divider there for the 2 nibbles, right, for each of my hex characters. So my first hex character will be 4 and 2 is 6. My second hex character will be 4 and 1, which is 5. So 101 in decimal is 65 in hexadecimal. 128, this is a good easy one here. 1, 2, 3, 4. Because remember, the first bit position has a value of 128, or the high order bit, the leftmost bit. So then what do we have here? We've got 8 and 0. So 128 is 80. 128 in decimal is 80 in hexadecimal. Let's now go to 143. So we know that 128 will be on. 64 would be 192, so that won't be on. And then we've got, what do we have? 64, 32, so 128 would be 160, so that's going to be off. So 128 plus 16 is 144, so that's going to be off. Put my divider in here. So 128 plus 8 is 136. So 136, or 143, if I subtract 136 from 143, I get 7, which I know 7 is going to be those last 3 bits right there, right? All right, so what do we have here? We've got 8 and then 15, so 8 fox. So 143 is 8 fox, or 8F. So 192, well, 128 plus 64 is 192. That's one of the nice round, easy ones that you'll become more comfortable with or more familiar with as you work more of these out. So then we have 8 plus 4. So do I put 12? No, remember, we're trying to go from decimal to hex. So 12 would be C is in Charlie, and then 0, because we have no bit positions on there. So 0xC0. I should probably strike these through to maintain consistency there. All right. Now we have 236. Well, we've got 128 plus 64 is 192. Plus 32 is 224. And I can't do 216 because that would take us to 240. So we'll have a 0 there. We'll do our line down here. So right now, where am I at? 128 and 64 is 192. Plus 32 is 224. So I'm only 12 away, because 224 plus 12 would be 236. So 12 out of these last 4, all I need to figure out is the 8 and the 4, that equals 12. And there we go. So 110 or 1110, 1100 is 236 decimal, and then 236 in decimal would be 8 plus 4 plus 2. That's 14. We know that that's E. And then 8 plus 4 is 12, and we know 12 is C. So 0x E C. All right, 242. 128 plus 64 is 192. Plus 32 is 224. Plus 16 is 240. So at that point, I'm only 2 away. And I know that that's the 2-bit position. So then everybody else would be zeros. So we've got all the bit positions on. Those are the easy ones, right? It's F and then 2. So 0xF2. And then we've got 250. Well, we know 128 plus 64 is 192. Plus 32 is 224. Plus 16 is 240. Plus 8 is 248. Well, if I'm at 248 and I need to get to 250, I only need 2 more. And everybody else will be zeros. We'll do that there. So again, the all ones makes it easy for us. It's F. And then 8 and 2 is 10, which would be A. So 0xFA, because A in hex is equivalent to 10 in decimal. And then 255, 1111, and this is our easy one, right? So it's all ones. We know that that is F, F, and in hex it would be 0xFF. And so a quick note on this, right? This is just simply a notation that's used to differentiate whether or not we're talking about hex. And again, you'll see this a lot in computer programming, because if I wrote 27, if I don't tell you that that is hex, right? In decimal, it's equal to 39. But if I don't tell you that this is hex, you might look at that and say, oh, well, he's talking about 27 decimal. And that's why sometimes you'll use the 0x in front of the value to indicate that that value is actually a hexadecimal value as opposed to a decimal value. All right, again, fantastic worksheets that have been put together here by Laura. So hopefully this has made the binary to decimal to hexadecimal conversion process a little easier for you. And that's it. That's all we've got. It was a very short worksheet this week. So I will see you guys on Tuesday evening, and enjoy the rest of your weekend.